Hello guys, welcome to another practice problem for Exam P. Today we'll be doing problem number 309 from the SOA's set of sample problems. So it reads as follows. A city with borders forming a square with sides of length 1 has its city hall located at the origin when a rectangular coordinate system is imposed on the city so that two sides of the square are on the positive axis. The density function of the population is f of xy equals 1.5 times the quantity x squared plus y squared, where x is greater than 0 and y is less than 1, 0 everywhere else. A resident of the city can travel to the city hall along a route whose segments are parallel to the city's borders. Calculate the expected value of the travel distance to the city hall of a randomly chosen resident of the city. All right, so if you need to write that rest of that problem down, just go ahead and pause the video and let's get started. So I've already drawn the city. So this is the city's borders, right? All right, but we're asked to find the expected value of a randomly selected person's route to the city hall, which is at the origin. Well, from our density, we can see that x is greater than 0 and y is less than 1. So the only place where people are living is up here in the first quadrant, right? All right. Actually, I should probably just say draw an arrow. Square in first quadrant is where people reside. Okay, so we're only worried about this right here, right? But we're asked to find the expected value of a person's route to the city hall, and it says that the route is only parallel. So we have all these different routes, right? We can do either this way, infinite amount of ways this way, or we can go this way, right, to the city hall. So there are x plus y ways, right? So if you have a horizontal line, like you're going this way, your x value is going to be 0, right? But if you're going horizontal, your y value is going to be 0. So it's going to be x plus y different ways. Okay. So right here, this is the expectation. So I've kind of already drawn it. So you have expectation of x plus y equals the double integral of 1.5 times x plus y times x squared plus y squared. I just rearranged the density. The x plus y part is the kicker for the expectation part. In this integral goes, the y values go from 0 to 1, and the x values go from 0 to 1. So pretty easy double integral. So the hard part is done, right? So you can see how we got to our expectation. So now let's integrate it. So I'm going to bring the 1.5 out. This is going to be 0 to 1, 0 to 1, and then x plus y times x squared plus y squared is x cubed plus x squared y plus xy squared plus y cubed. And I integrated it with respect to x first, so dx dy. So this equals 1.5 times the integral 0 to 1 of x to the 4th over 4 plus x cubed y over 3 plus x squared y squared over 2 plus y cubed x, or sorry, let's do xy cubed to stay consistent, to keep my x's in front. And this is integrated from 0 to 1 dy. So this ends up being 1.5 times the integral 0 to 1 of 1/4 plus y over 3 plus y squared over 2 plus y cubed dy. And then this implies 1.5 times, sorry, ears hurt me. Sorry about that. So this equals, as I said, 1.5 times 1/4 y plus y squared over 6 plus y cubed over 6 plus y to the 4th over 4, where x equals 0, x equals 1. So finally, your answer is going to be 1.5, and then this is 1/4 plus 1/6 plus 1/6 plus 1/4. And then if you plug this in your calculator, you get 5/4. And that's your answer. All right. Thank you for watching. And as always, like, subscribe, comment if you have any questions about any of my solutions, and hope y'all have a great day. Thank you.